Out there, in the unimaginable vastness between stars and galaxies, lies a mystery so profound that it challenges everything we thought we understood about the cosmos. We look up at the night sky and see a scattering of glittering lights, but what if I told you that the universe holds far more than meets the eye, or even the most powerful telescopes? What if some of the largest structures in existence are completely invisible, made of a substance we can't see, don't understand, and that might just redefine the laws of physics as we know them? These are the dark galaxies, and while the name itself sends a chill down the spine, their true nature is even more unsettling. Scientists once believed that galaxies were primarily made of stars, gas, and dust, all things that give off light or can be observed indirectly. But dark galaxies flip that idea on its head. They are colossal structures, some even larger than our own Milky Way, that contain little to no stars. Instead, they are dominated by dark matter, an enigmatic substance that doesn't emit, absorb, or reflect light. It's utterly invisible, yet its gravitational pull is immense enough to hold galaxies together and even tear them apart. Imagine an entire city bustling with unseen energy, forces moving in the shadows, shaping reality from behind a veil. That's what researchers are confronting, and it's forcing them to question not only how galaxies form, but what the universe is truly made of. Today, we're venturing into the heart of this cosmic enigma as we explore 25 dark galaxies that defy explanation and, in some cases, instill genuine fear in the scientific community. From silent giants lurking in the void to strange, starless structures that challenge our most fundamental theories, each of these cosmic puzzles pulls us deeper into a story far stranger than fiction. This isn't just a tour of distant space. It's a journey to the edges of understanding, where every discovery raises more questions than answers. So join me as we shine a light on the darkness and uncover what makes these shadowy realms some of the most haunting and fascinating subjects in modern astronomy. Our journey into the abyss begins with a galaxy so faint, it was only discovered in 2015, hiding in plain sight within the crowded Coma Cluster. This is Dragonfly 44, and it is a cosmic paradox. To the eye, it is a ghost, a wispy, ethereal smudge of light so diffuse that it barely registers. If our own Milky Way were a bustling metropolis of stars, Dragonfly 44 would be a handful of distant lanterns scattered across an endless, empty plain. Yet, this apparent emptiness is a deception. Measurements of the motions of its few visible stars revealed something astonishing. This faint galaxy possesses a gravitational pull rivaling that of the Milky Way. The only possible explanation is that this seemingly insignificant object is almost entirely composed of dark matter, with a staggering 99.99% of its mass being completely invisible. This revelation sent shockwaves through the astrophysics community. It's the equivalent of finding a single, floating feather that somehow weighs as much as a freight train. The existence of Dragonfly 44 directly challenges the very models we use to understand how galaxies are born and how they evolve. According to our theories, a galaxy with so few stars should never have been able to accumulate and hold onto such an immense halo of dark matter. It shouldn't exist. Its presence suggests that dark matter can, under conditions we don't yet comprehend, clump together into massive structures without igniting the star formation we always assumed was a necessary part of the process. This forces scientists to confront an unsettling possibility. What if Dragonfly 44 isn't a bizarre outlier, but merely the first of a vast, hidden population of dark galaxies we've been blind to all along? The thought that the universe could be teeming with these invisible giants, fundamentally altering the cosmic balance of power, is a profoundly humbling and, yes, a terrifying prospect for those trying to map the true architecture of reality. But if Dragonfly 44 represents a ghost from a distant cluster, our next subject hits far closer to home, serving as a chilling reminder that we don't need to look billions of light years away to find the universe's dark secrets. Nestled in the constellation Segue, a tiny, unassuming satellite galaxy orbits our Milky Way. This is Segue 1, and it holds the disturbing title of being one of the darkest objects ever identified. To our telescopes, it appears as little more than a sparse sprinkling of a few hundred ancient stars, a faint and dwindling ember in the vast galactic night. Yet, the motion of those few stars tells a story of immense and hidden power. The stars within Segue 1 are moving at velocities so high that the gravitational force required to keep them from flying apart is enormous. The resulting mass-to-light ratio is staggering. For every single bit of light its stars emit, Segue 1 possesses over 3,000 times more mass. This incredible ratio leads scientists to conclude that this faint speck is, by mass, over 99% dark matter. It is less a galaxy of stars and more a colossal, invisible anchor of dark matter that just happens to have a handful of stars caught in its overwhelming gravitational grip. The profound implications of Segue 1 are what truly generate a sense of unease among astronomers. Its existence so close to us suggests that what we perceive as the familiar structure of our local galactic neighborhood, the Milky Way and its entourage of orbiting satellite galaxies, might be a complete illusion. We have long mapped the cosmos by light, cataloging what shines, but Segue 1 is a powerful indicator that we are only seeing the tip of the iceberg. If this one, tiny and incredibly dark object was so difficult to find right on our cosmic doorstep, how many other invisible galaxies are lurking undetected in the immediate vicinity of the Milky Way? Our current census of satellite galaxies numbers around 60, but cosmological simulations suggest there should be hundreds, even thousands more. The terrifying possibility is that they are already here, but we cannot see them because they are composed almost entirely of dark matter, just like Segue 1. These dark satellites could be silently weaving through our galactic halo, their invisible gravitational fields subtly influencing the motion of stars we can see, warping the fabric of our galaxy in ways we are only beginning to detect. This isn't just a remote curiosity, it's a hidden architecture of reality existing all around us, a silent, unseen ocean of dark matter in which our luminous galaxy is merely a floating ship. Moving from the silent, massive presence of Segue 1, we venture to another faint dwarf galaxy orbiting the Milky Way, one where the hidden nature of dark matter may be revealing itself in a far more violent and spectacular fashion. This is Triangulum II, a tiny, incredibly faint collection of stars located about 98,000 light-years from Earth. At first glance, it seems unremarkable, a mere wisp of stellar light, another quiet satellite in our galaxy's entourage. But look closer, and you find something deeply unsettling happening at its core. The few stars within Triangulum II are moving at extraordinary speeds, indicating a gravitational grip so powerful that the galaxy must be almost entirely composed of dark matter. In fact, its density of dark matter is among the highest ever measured, creating an environment of such intense gravity that it effectively acts as a natural particle trap, concentrating dark matter at its center to levels rarely seen elsewhere. This extreme density is where the story takes a terrifying turn. Some of the most powerful space-based telescopes have detected a faint but persistent glow of high-energy gamma-ray radiation emanating from the very heart of Triangulum II. This is not the gentle light of stars, this is the signature of immense energy release, the kind produced by matter and antimatter annihilating one another in a violent burst. For many scientists, this gamma-ray signal is a potential smoking gun, the first direct evidence of a long-theorized but never confirmed process, dark matter annihilation. The prevailing theory suggests that dark matter could be made of weakly interacting massive particles, or WIMP. According to this idea, when two of these particles collide under the right conditions of incredible density and pressure, they could annihilate each other, converting their mass directly into pure energy and releasing a shower of gamma rays in the process. The core of Triangulum II, with its unimaginable density of dark matter, could be the perfect crucible for this catastrophic particle physics. The implications of this are staggering and more than a little frightening. It suggests that dark matter is not just a passive, invisible scaffold holding galaxies together. Instead, it could be an active participant in the cosmos, capable of engaging in its own form of violent particle physics that we are only now beginning to detect. If this interpretation is correct, we are witnessing the hidden components of the universe tearing themselves apart in a continuous, high-energy reaction. This transforms our understanding of dark matter from a mysterious gravitational glue into a dynamic substance with its own laws of interaction, a shadow universe of physics playing out right beside our own. For researchers, this is both a thrilling opportunity and a source of profound anxiety. Confirming dark matter annihilation would be a Nobel Prize-winning discovery, finally cracking a mystery that has persisted for decades. But it would also force us to accept that the universe is filled with invisible matter constantly engaging in energetic self-destruction, a silent background violence that has been shaping the cosmos since its very beginning. Triangulum II, therefore, is not just a dark galaxy, it is a potential window into the ferocious heart of darkness itself. If Triangulum II shows us the potential for violent particle physics in the dark, our next discovery reveals a ghost of a completely different scale, one whose sheer size and proximity force us to confront a humbling blind spot in our cosmic senses. Imagine a giant, one as massive and vast as the Large Magellanic Cloud, that brilliant, star-filled satellite galaxy that has lit up the southern hemisphere's night sky for millennia. Now imagine that same colossal object, but one that is almost completely dark, a phantom so diffuse that it has been hiding in the shadows of our own galactic backyard, utterly invisible until just a few years ago. This is not a thought experiment, this is Antlia II, discovered in 2018 by astronomers sifting through data from the Gaia spacecraft. Antlia II is a cosmic paradox that defies easy explanation. It is a dwarf galaxy, but one that operates on a gargantuan scale. In terms of physical size, it is as enormous as the Large Magellanic Cloud, stretching across a vast volume of space. Yet, where the Large Magellanic Cloud blazes with the light of billions of stars, Antlia II is eerily dim. It emits roughly 10,000 times less light than its brilliant counterpart. To put that into perspective, if the Large Magellanic Cloud is a sprawling, well-lit metropolis, Antlia II is a deserted city of the same size, with only a few faint candles flickering in its empty streets. It is an incredibly low-density ghost, a wispy giant whose few stars are spread so thin that the galaxy barely registers against the blackness of space. What allowed this phantom to finally be seen was not its light but its gravity. The Gaia mission was meticulously mapping the precise positions and motions of billions of stars in the Milky Way. Researchers noticed a subtle but coherent wobble, a distinct gravitational tug affecting the movement of a specific group of stars. This tug was the signature of a hidden source of immense mass, a gravitational distortion revealing the presence of something massive lurking behind the veil. By tracing this effect, they pinpointed Antlia II, a galaxy revealed not by the light it emitted, but by the invisible hand of its gravity pulling on the stars around it. The discovery of such a large, dark, and incredibly diffuse object so close to the Milky Way sends a genuine chill through the astrophysics community. It directly challenges the standard model of galaxy formation, which struggles to explain how a structure so massive could have so few stars and such a feeble presence. Its existence suggests that our conventional methods of mapping the universe by looking for light are fundamentally flawed. We have been cataloging the cosmos by the glittering chandeliers, completely missing the massive, dark walls of the room. The most frightening implication of Antlia II is the stark question it poses. If a galaxy this large, this close, remained hidden from us until now, what else is out there? How many other Antlia IIs, these ghost giants of dark matter and ancient stars, are currently orbiting the Milky Way, completely invisible to our telescopes? Our galaxy's gravitational halo could be teeming with these massive, dark satellites, a hidden entourage whose combined mass could far outweigh everything we can see, silently dictating the motion and ultimate fate of our Milky Way in ways we are only beginning to imagine. Just when astrophysicists thought they were beginning to understand the rules of the cosmos, the universe presented them with a paradox so baffling it seemed to break physics itself. If dark matter is the invisible glue holding galaxies together, then a galaxy without it should, by all accounts, simply fly apart. It shouldn't be able to exist. And yet, in 2018, researchers using the Hubble Space Telescope and other observatories discovered exactly that, a galaxy that defies the very foundation of modern cosmology. This is NGC 1052 DF2, and its existence is so profoundly unsettling that it forces us to question everything we thought we knew. Located about 65 million light-years away in the constellation Cetus, NGC 1052 DF2 is what's known as an ultra-diffuse galaxy. It is enormous, roughly the size of our Milky Way, but contains only about 1/200th of the stars. This makes it incredibly faint and transparent. You could practically see straight through it. The initial intrigue around this galaxy was its strange appearance, but the real shock came when scientists measured the motions of its star clusters to calculate its mass. The results were absolutely staggering. The visible mass of the stars and gas accounted for nearly all the gravity present. There was no room for a massive halo of dark matter. In fact, follow-up observations confirmed the unthinkable. This galaxy appears to have no dark matter at all. The discovery sent a tremor through the scientific community, creating a crisis in cosmology. For decades, the entire concept of dark matter was built upon the consistent observation that galaxies consistently have far more mass than their visible components can account for. Dark matter wasn't just a theory, it was the explanation for a universal, repeatable phenomenon. NGC 1052 DF2 shatters that consistency. It is the exception to the rule, the cosmic rebel that looks at the established model and simply says no. This presents scientists with a terrifying pair of possibilities, and both are deeply unnerving. The first option is that our methods for detecting and measuring dark matter are fundamentally flawed, casting doubt on decades of research and the very evidence we've used to build our model of the universe. If we can't trust the measurements that prove dark matter exists, we are back at square one. The second, and perhaps even more frightening possibility, is that our understanding of dark matter itself is incomplete or wrong. Perhaps dark matter is not the simple, ubiquitous particle we've imagined. Maybe it can be separated from visible matter under certain extreme conditions, or perhaps it interacts with itself or other forces in ways we haven't begun to comprehend, allowing it to be stripped away or made absent. The presence of this galaxy suggests that the formation of galaxies might be a far more complex and diverse process than our tidy models allow. It opens the door to a universe where galaxies can form through multiple, unknown pathways, some requiring dark matter and some not. This doesn't just add a new chapter to the book of astronomy. It suggests we might have entirely misread the first few chapters. NGC 1052 DF2 is not just a missing dark matter galaxy. It is a profound reminder that for every rule we think we've uncovered about the cosmos, the universe is ready and waiting to show us an exception. Our journey now takes us beyond the Milky Way's sphere of influence to our nearest major galactic neighbor, the Andromeda Galaxy. orbiting this colossal spiral is a haunting collection of satellite galaxies, and among them, one stands out for its profoundly unsettling nature, Andromeda 19. Discovered in the early 2000s, this object is the definition of a cosmic ghost. It is an ultra-diffuse galaxy that stretches across a vast expanse of space, comparable in size to many other dwarf galaxies. But where its siblings would contain millions of stars, Andromeda 19 holds almost none. Its stellar population is so sparse, so desperately thin, that it barely registers against the void. If a typical dwarf galaxy is a small town, Andromeda 19 is a handful of people scattered across an entire continent, unaware of each other's existence. The sheer emptiness of this galaxy is what makes it so conceptually frightening to astronomers. It represents a dark matter halo that, for reasons we don't understand, largely failed at the one job we thought was fundamental: building things. Our standard model of cosmology suggests that after the Big Bang, dark matter acted as a gravitational scaffold. Its immense pull drew in ordinary gas and dust, which then cooled, condensed, and eventually ignited into the stars that light up the universe. Andromeda 19 presents a direct challenge to this elegant story. Here is a massive halo of dark matter, a gravitational potential well deep enough to have formed a significant galaxy that, for all intents and purposes, did nothing. It gathered its dark matter and then simply stopped, failing to attract or retain the baryonic matter needed to create a visible structure. This forces a deeply uncomfortable question: why? Why did star formation fail so catastrophically in this specific halo? Scientists propose a few chilling possibilities. Perhaps the gas that was drawn into the halo was heated by the intense ultraviolet radiation from the earliest stars and galaxies in the universe, preventing it from ever cooling down enough to collapse and form stars. Or maybe the gravitational environment around Andromeda was so tumultuous that any nascent stars were ripped away by tidal forces before they could establish a foothold, leaving behind a dark, barren core. The existence of Andromeda 19 suggests that the process of galaxy formation is not a guaranteed, automatic outcome of a dark matter halo. It can be stillborn. It can fail. This means the universe could be filled with countless millions of these empty, dark halos, invisible structures that never lit up, never got a chance to become a true galaxy. They are the silent, unseen majority, the cosmic blanks in a story we thought was all about the shining lights. Andromeda 19 isn't just a faint galaxy. It is a monument to cosmic failure, a stark reminder that the conditions for life and light are not a universal default, but a precious and perhaps rare exception in a dark and indifferent universe. While the ghost of Andromeda 19 shows us a dark matter halo that failed to form stars, another discovery within our own cosmic neighborhood reveals a structure so vast and yet so invisible that its very existence forces us to rewrite the definition of a galaxy. Meet Crater II, a behemoth hiding in the constellation of the Cup orbiting our Milky Way. The incredible fact about Crater II is not just that it's there, but that it managed to remain hidden from us for so long, only being uncovered in 2016. This isn't some tiny, distant speck. By sheer physical size, Crater II is the fourth largest dwarf galaxy known to be orbiting the Milky Way. It stretches across a staggering 6,000 light-years. To put that into perspective, if you were to place it in the night sky, it would appear twice as large as the full moon. Yet, despite its immense physical footprint, it emits so little light that it completely eluded every survey and telescope for decades. This paradox of immense size and incredible faintness is what makes Crater II so deeply unsettling. It is a ghostly giant, a celestial paradox. Its stars are so few and spread so thin that the galaxy possesses a surface brightness verging on the absolute darkness of the background sky itself. You could be looking directly at it and see nothing but empty space. It was only through meticulous analysis of data from the VLT survey telescope in Chile that astronomers noticed a subtle, coherent grouping of stars moving together through the halo of the Milky Way. This wasn't a bright cluster, it was a vast, tenuous swarm, a galactic phantom revealed only by the synchronized motion of its constituent stars against the backdrop of the cosmos. The realization of what they had found sent a ripple of anxiety through the astronomical community. The sheer scale of Crater II proves that our methods of cosmic discovery are fundamentally biased toward things that shine. We have been meticulously mapping the heavens, confident in our catalogs, while a structure of this immense size was drifting right past us unseen. This immediately raises a terrifying and humbling question. If something as large as Crater II could stay hidden for so long, what else is out there? How many other massive, dark galaxies are currently orbiting the Milky Way, their presence felt only through the faintest gravitational tugs on the stars we can see? Our galactic neighborhood, which we thought we knew so well, might be teeming with these invisible giants. They are the silent passengers on our galactic journey, their dark matter halos weaving through our own, their gravitational influence potentially shaping the destiny of the Milky Way in ways we are only beginning to fathom. Crater II is more than a galaxy. It is a stark warning about the limits of our perception and a chilling hint that the true architecture of the universe is still largely hidden in the shadows. But the story of dark galaxies is not just about discovering what we cannot see. It is also about learning to see the universe in an entirely new way. This brings us to one of the most pivotal and unsettling discoveries in the entire field. A galaxy that wasn't found by its starlight, but by its silent radio whisper. This is Virgo 21, and its existence rewrote the rules of cosmic discovery. Located approximately 50 million light-years away within the immense Virgo cluster, Virgo 21 was first detected not by an optical telescope, but by a radio observatory tuned to listen for a very specific frequency. The 21-centimeter wavelength emitted by neutral hydrogen gas. The signal was faint but unmistakable, a clear signature of a vast reservoir of cold gas swirling through the void. The sheer amount of hydrogen detected suggested the presence of a significant galaxy, potentially containing billions of solar masses of material. Yet, when astronomers pointed their most powerful optical telescopes toward that exact same patch of sky, they saw nothing, absolutely nothing. There was no glow of stars, no faint smudge of a distant island universe. There was only the inky blackness of empty space. This was the terrifying paradox. The radio data insisted a massive rotating structure was there, but the light data showed a complete void. The only explanation that fit was both simple and revolutionary. They had found a galaxy made almost entirely of dark matter, whose gravitational pull had gathered a cloud of primordial hydrogen gas, but which had utterly failed to form a single star. The implications of Virgo 21 sent a profound shock through the world of astronomy. For the first time, we had concrete evidence that a galaxy could, in fact, be built from dark matter and nothing else. It proved that the dark matter halos we had theorized about could indeed exist independently, as barren structures hosting nothing but trace amounts of gas. This was a galaxy in its most primitive, failed state, a cosmic ghost ship adrift in the cluster, its holds empty, its decks forever dark. The discovery was terrifying because it demonstrated that star formation is not an inevitable consequence of a galaxy's existence. It can be stifled, prevented, or simply never begin, leaving behind these dark, primordial relics from the early universe. Virgo 21 forces us to wonder just how many of these starless ghosts are drifting through the cosmos, invisible to all but the most specialized detectors. It suggests that for every brilliant, star-filled galaxy like our Milky Way, there could be countless dark counterparts, silent and unseen, forming a hidden majority of the universe's true structure. If the discovery of NGC 1052 DF2 felt like a single, baffling crack in the foundation of cosmology, then its cosmic sibling, NGC 1052 DF4, is the quake that followed, threatening to bring the entire structure down. Found in the same region of space and studied by the same team, DF4 was revealed to share the same impossible characteristic, a glaring, profound lack of dark matter. Where DF2 was the first shocking exception, DF4 was the terrifying confirmation that this was not a fluke. It proved that galaxies without dark matter were a genuine class of object, a new and bizarre category of celestial body that our models never predicted and still struggle to explain. The methodology used to confirm DF4's missing mass was meticulous and left little room for doubt. Astronomers employed two independent techniques to measure its mass. The first, as with DF2, involved tracking the motions of its star clusters. The speeds of these clusters were slow and sedate, indicating a gravitational field so weak that it could be entirely accounted for by the paltry number of stars visible. There was no extra pull, no sign of an unseen hand holding everything together. The second technique measured the galaxy's total mass by analyzing how its gravitational field subtly distorts the light from more distant background galaxies, a phenomenon known as weak gravitational lensing. Both methods arrived at the same staggering conclusion. The mass you see is the mass you get. The dark matter, the substance thought to be the fundamental building block of all galaxies, was simply absent. This 1-2 punch of DF2 and DF4 creates a crisis that goes far deeper than a simple anomaly. It presents scientists with a terrifying philosophical dilemma. On one hand, the evidence for dark matter's existence is overwhelming, from the rotation curves of spiral galaxies to the gravitational lensing of massive galaxy clusters. On the other hand, here is direct observable proof that at least some massive structures can and do form without it. How do we reconcile these two contradictory truths? The fear this generates is not about the existence of dark matter itself, but about the completeness of our understanding. It forces the uncomfortable admission that our standard model of galaxy formation, a framework built over decades, might be missing crucial pieces of physics. We may have been right about the what dark matter exists but could be completely wrong about the how. This has led to a flurry of anxious and innovative theories. One disturbing possibility is that these strange galaxies are the aftermath of a cosmic catastrophe. Perhaps DF2 and DF4 were once normal galaxies, rich with dark matter, that ventured too close to the massive elliptical galaxy NGC 1052. In this scenario, the immense tidal forces of the larger galaxy could have violently stripped away their dark matter halos, ripping the invisible scaffolding out from under them while leaving the visible stars largely intact, like pulling a tablecloth off a set table without disturbing the plates. This tidal stripping theory is compelling, but it raises its own frightening questions. The process would have to be incredibly precise and efficient, and it suggests that the serene space between galaxies is not empty but filled with these invisible, wrecked halos of dark matter, the ghostly remains of galactic dismemberments. Another, even more radical idea is that dark matter itself is not a simple, passive substance but something that can interact with itself through forces we don't yet understand. Perhaps under certain conditions, dark matter particles can experience friction or collisions, causing them to slow down and fall away from their host galaxies, leaving the stars behind. This would mean dark matter has a rich and complex physics of its own, a hidden dynamics operating in parallel to our own world of light and matter. The existence of NGC 1052 DF4 doesn't just ask where the dark matter went. It forces us to question if we ever truly understood what it was in the first place, pushing us toward the unsettling frontier where known physics ends and true mystery begins. Leaving behind the unsettling voids of the missing dark matter galaxies, our journey takes us to the opposite extreme of the cosmic spectrum, to one of the most ancient and primordial structures ever discovered. This is Tucana II, a relic from the dawn of time that presents a terrifying vision of how the first galaxies were forged not in starlight but in overwhelming darkness. Located about 163,000 light-years from Earth, Tucana II is an ultra-faint dwarf galaxy, a class of objects so dim and sparse it pushes the limits of detectability. To our most powerful telescopes, it appears as a mere whisper of light, a scant collection of a few thousand ancient stars. For decades, it was catalogued as just another faint satellite of the Milky Way, a cosmic afterthought. But recent observations have revealed its true, terrifying nature, showing that this faint smudge is in fact the heart of a monster. The revelation came when astronomers studied the motions of stars not just at Tucana II's core, but in its outermost reaches. They discovered a population of stars moving at incredibly high speeds, stars that were so far from the center that they should have been gravitationally unbound and flung into the void long ago. The fact that they remain tethered to this faint galaxy indicates only one thing: an immense, unseen gravitational force is holding them in place. Calculations of the mass required to create this pull were absolutely staggering. Tucana II's dark matter halo is estimated to be 3 to 5 times more massive than anyone had previously thought, meaning it possesses an amount of dark matter that is hundreds, if not thousands, of times greater than the total mass of all its visible stars combined. This is not just a galaxy with dark matter, this is a dark matter fortress with a few specks of starlight trapped inside. What makes this discovery so profoundly significant and frankly concerning for cosmologists is the confirmed age of Tucana II. The stars at its outer edges are among the most ancient ever measured, with metallicity levels so low they indicate they formed from the pristine, unpolluted gas of the very early universe. This confirms that Tucana II is a first-generation galaxy, a fossil from the universe's infancy, and its extreme dark matter dominance forces a terrifying rewrite of the story of cosmic dawn. Our prevailing models suggested that the first galaxies were small, humble affairs that gradually accumulated more mass and dark matter over billions of years through mergers and accretion. Tucana II screams that this is wrong. It shows us that some of the very first structures to emerge after the Big Bang were already overwhelmingly dominated by dark matter from their very inception. This raises a chorus of alarming questions that strike at the heart of modern cosmology. How did such massive dark matter halos form so quickly, so early in the universe's history? What unknown physical processes allowed dark matter to clump together with such efficiency, creating these gravitational titans before the first stars had even finished their first brilliant lives? The existence of Tucana II suggests that the infant universe was a place of extreme and violent contrasts, where dark matter ruled with an iron fist and the first flickers of starlight were utterly subservient to the invisible architecture of the cosmos. It forces scientists to confront the possibility that our understanding of dark matter's behavior in the extreme densities of the early universe is fundamentally incomplete. This ancient galaxy is a direct message from 13 billion years in the past, and its message is a humbling one. The seeds of the cosmic structures we see today were not planted in a gentle garden, but in a ferocious and hidden storm of dark matter whose true nature remains locked in darkness. But the mystery of dark matter's influence doesn't only reside in the ancient past or in distant clusters. It also manifests in bizarre, borderline objects lurking much closer to home, defying our most basic attempts at classification. This brings us to Willman I, an enigma floating in the halo of the Milky Way that has become a profound source of anxiety for astronomers. Is it a star cluster? Is it a dwarf galaxy? The answer is far from clear, and its ambiguous nature forces us to confront the unsettling reality that our clean, human-imposed categories for cosmic objects are perhaps too simplistic for a universe that thrives on complexity. Discovered by astronomer Beth Willman in 2004, this faint object is incredibly small and dim, containing only a few hundred ancient stars. To the untrained eye, its image would be easily mistaken for a faint globular cluster, a tight, spherical grouping of stars bound together by gravity. But the devil, as they say, is in the dynamics. When scientists measured the velocity dispersion of its stars, essentially how fast they are moving relative to one another, they found something that shattered the simple cluster hypothesis. The stars were moving at speeds far too high to be explained by the gravitational pull of their visible companions alone. The only way to account for this frantic motion was to invoke the presence of a massive, unseen anchor, dark matter. The calculations revealed a shocking mass-to-light ratio, indicating that Willman I is over 99% dark matter by mass. This is a value utterly unheard of for a globular cluster, which are typically devoid of dark matter. This tiny, faint smudge of light possesses a gravitational signature that rivals that of much larger dwarf galaxies. This is where the true anxiety sets in for the astronomical community. Willman I exists in a frustrating and terrifying gray zone. It has too many stars and is too spatially extended to be a conventional star cluster, yet it is far too small and dim to fit neatly into the category of a dwarf spheroidal galaxy. It is a cosmic chimera, a hybrid object that our textbooks never prepared us for. Its very existence suggests that the boundary between a massive star cluster and a minuscule galaxy is not a bright line, but a blurry frontier dominated by dark matter. This forces a deeply uncomfortable question. How many other objects have we misclassified? Have we been looking at the cosmos through a lens that only allows for either-or, when the reality might be a continuous spectrum of dark matter-dominated systems? The implications of Willman I ripple outwards, challenging foundational ideas about how such structures form. If it is a star cluster, how did it acquire such an immense halo of dark matter, a feat thought to be impossible? If it is a dwarf galaxy, why did it form so few stars, leaving it a faint, failed shadow of its potential? This single, puzzling object acts as a key to a hidden door, suggesting the universe might be filled with a whole population of these dark matter-rich intermediates that we have previously overlooked or forced into the wrong categories. Willman I is not just a curiosity, it is a stark warning that our understanding of cosmic structure is still in its infancy, and that the most unsettling discoveries are often those that don't fit anywhere at all. Just as our own Milky Way is surrounded by its own entourage of dark and mysterious satellites, our closest galactic neighbor, the colossal Andromeda Galaxy, hosts its own haunting collection of faint companions. Among them, one stands out as a quintessential example of the invisible architecture that permeates our local universe, Andromeda 21. This object is a textbook diffuse dwarf spheroidal galaxy, a classification that sounds academic but translates to something profoundly unsettling, a ghost. It was discovered in 2005 not by seeing a bright smudge of light, but by meticulously identifying a subtle, coherent grouping of incredibly faint stars moving together through space, a swarm of ancient suns so sparse they barely register against the blackness. The defining characteristic of Andromeda 21, and the source of its scientific significance, is its extraordinarily low surface brightness. This is a measure of how much light is emitted across a given area of space. For a typical galaxy like Andromeda or the Milky Way, that number is high, creating the brilliant swath of light we see in the night sky. For Andromeda 21, the surface brightness is so desperately low that it verges on the imperceptible. Its stars are not clustered tightly together, they are flung across a vast volume, isolated from one another by light years of emptiness. If you were to float within it, the sky would appear nearly as black as the void between galaxies, with only a few distant and feeble points of light to break the overwhelming darkness. Yet, this apparent emptiness is a profound deception. Measurements of the motions of those few, lonely stars reveal they are hurtling along at tremendous speeds. To be moving that fast and still remain bound to this faint structure requires a gravitational anchor of immense power. The math is inescapable. Andromeda 21, for all its apparent emptiness, possesses a mass-to-light ratio that is staggering. The overwhelming majority of its substance, well over 99%, is the invisible grip of dark matter. It is not a collection of stars that happens to have some dark matter. It is a massive globe of dark matter that has, almost as an afterthought, managed to ensnare a handful of ancient stars. The true fear instilled by Andromeda 21 does not come from its individual properties but from what it represents. It is not a bizarre outlier or a cosmic freak. On the contrary, it is frighteningly normal for its class. It is one of dozens of such faint, dark matter-dominated satellites orbiting Andromeda, and it mirrors the population of similar dark satellites like Segue I and Crater II that orbit our own Milky Way. This prevalence is what forces a chilling realization upon astronomers. These dark galaxies are not rare exceptions. They are the rule. They are the standard, most common type of galaxy in the entire local group of galaxies, and likely in the entire universe. Our cosmic neighborhood is not primarily made up of brilliant spirals and ellipticals. It is constructed from a vast, unseen scaffolding of dark matter halos, most of which are either completely dark or, like Andromeda 21, have only managed to light a few pathetic candles in the immense void. This means the universe we see, the glittering tapestry of stars and galaxies, is merely a decorative overlay on a hidden reality, a luminous froth on a deep, dark, and invisible ocean. Pushing the boundaries of what we can even call a galaxy, we now venture into the realm of the ultra-faint, where the very definitions of cosmic structure begin to break down. In the constellation Hercules, astronomers have identified one of the most ghostly objects ever catalogued, a satellite of the Milky Way so ethereal it wasn't found by seeing a shape or a glow, but by counting nothing. This is the Hercules ultra-faint dwarf galaxy, and its discovery method alone is a testament to its profoundly unsettling nature. Researchers weren't looking at an image and spotting a smudge. They were performing a statistical analysis of the density of stars across the sky, searching for any region where the number of stars per unit area was slightly, almost imperceptibly, higher than the surrounding background. It was a subtle statistical anomaly, a tiny overdensity in a vast sea of data that betrayed the presence of this cosmic phantom. What they found was less a galaxy and more a suggestion of one. The Hercules dwarf contains only a few 100,000 stars flung across an enormous volume of space. If you were to travel through it, the distances between these ancient suns would be so vast that the concept of a galaxy would feel almost meaningless. It is a desperately empty place. And yet, this incredible sparseness is not what makes it terrifying. The true fear comes from measuring the motions of those few, lonely stars. Despite having a stellar population so tiny it verges on non-existent, the stars within the Hercules dwarf are moving at astonishingly high velocities. To keep these fast-moving stars from simply flying off into the intergalactic void requires a tremendous amount of gravity, a gravitational grip far stronger than the combined pull of all its visible stars could ever provide. The math leads to one inescapable and disturbing conclusion. This faint wisp of a structure is embedded within a massive, dense halo of dark matter. Its mass-to-light ratio is one of the highest ever measured, meaning the amount of dark matter present is astronomically disproportionate to the paltry number of stars it contains. This presents a direct and frightening challenge to our most fundamental computer simulations of the universe, specifically the cold, dark matter model. These simulations predict a clear and tidy relationship. The more massive a dark matter halo is, the more stars it should be able to form and hold onto. A small, low-mass halo should only ever be able to form a small, faint galaxy. But the Hercules dwarf galaxy is a cosmic rebellion. It possesses a massive dark matter halo that, according to all our models, should have been more than capable of forming a much brighter, more substantial galaxy, perhaps even 1,000 of times more luminous than what we see. Its existence suggests something is profoundly wrong with our understanding. The terrifying possibility it raises is that dark matter might not cluster in the neat, predictable ways we have always assumed. Perhaps the process of galaxy formation is far messier and more inefficient than our simulations allow, with some halos failing catastrophically to convert their gas into stars due to early radiation, tidal forces, or some other mechanism we haven't yet considered. Or even more disturbing, it could imply that the nature of dark matter itself is more complex, that it might have properties allowing it to form dense clumps on small scales that our current physics cannot yet explain. The Hercules ultra-faint dwarf is a ghost that haunts our models, a faint signal from the dark that tells us we are still missing a crucial piece of the puzzle, and that the hidden majority of the universe operates by rules we have only just begun to imagine. Now, let's turn our attention to a galaxy that presents a completely different kind of puzzle, one that blurs the line between the living and the dead. This is Leo T, a fascinating and deeply peculiar object located about 1,300,000 light-years away. Leo T defies easy categorization, and that's precisely what makes it so significant. It's not a blazing spiral nor a completely failed dark ghost. It's something in between, a cosmic transitional form that holds clues to one of the greatest mysteries, the role dark matter plays in the very spark of creation. Most ultra-faint dwarf galaxies we've encountered are like cosmic retirement homes. They contain only ancient population 2 stars, old red giants that formed over 12 billion years ago. These galaxies are fossils, places where star formation ceased in the universe's infancy and never restarted. Leo T shatters this expectation. When astronomers studied its light, they found a breathtaking duality. Yes, it contains that expected population of ancient stars, but it also hosts a much younger generation of stars, some as young as 1 billion years old. Even more astonishing, observations revealed that Leo T is still holding onto a significant reservoir of neutral hydrogen gas, the raw fuel for starbirth. This is utterly bizarre for a galaxy of its size and mass. That gas should have been stripped away eons ago by the gravitational tides of the Milky Way or evaporated by ultraviolet radiation from intergalactic space. The fact that it hasn't suggests something is protecting it, providing a gravitational shield that allows this tiny galaxy to cling to the very stuff of life. That something, of course, is dark matter. Leo T possesses a significant dark matter halo, one that is massive enough to create a deep gravitational well, sheltering its gas from being ripped away and even allowing it to slowly collapse and form new stars over billions of years. This presents a terrifyingly beautiful paradox for scientists. We have dark matter-dominated galaxies like Segue 1 that are utterly sterile, dark matter fortresses where star formation was strangled at birth. And then we have Leo T, another dark matter-dominated galaxy, where that same invisible substance appears to be the nurturing force, the protective cocoon that has allowed a tiny, fragile ecosystem of stars to persist and even rejuvenate itself across cosmic time. This duality is what creates a genuine sense of fear and wonder among researchers. It forces them to ask a question that has no simple answer. Does dark matter suppress star formation or enable it? The terrifying truth emerging from the study of objects like Leo T is that it can do both. It seems the influence of dark matter is not a simple on-off switch but a complex dial, with the ultimate outcome depending on a delicate and poorly understood balance of factors. The mass of the halo, its density, the timing of its formation, and its environment all seem to play a role in determining whether a galaxy becomes a brilliant beacon of light or a dark, silent tomb. Leo T sits precariously on that knife's edge, a testament to how finely tuned and fragile the process of cosmic creation can be. Its continued, hesitant starbirth is a direct challenge to our models, suggesting that the relationship between the visible and invisible universe is far more intricate and conditional than we ever dreamed. While Leo T shows us a dark matter halo acting as a protective shield, other cosmic structures reveal a far more violent relationship between the visible and invisible universe, demonstrating that even destruction can leave a lasting, ghostly imprint. This brings us to Bootes III, a celestial spectre that haunts the northern constellation of the Herdsman. Unlike the cohesive, albeit faint, shapes of other dwarf galaxies, Bootes III presents a far more disturbing sight. It is a galaxy in its death throes, a structure that has been violently torn apart. To our telescopes, it appears not as a defined sphere or disk, but as a faint, ethereal smear of stars, a ghostly streak stretched across the sky. This is the unmistakable signature of tidal disruption, the result of a smaller galaxy venturing too close to the immense gravitational field of our Milky Way and being literally pulled apart over billions of years. The process is a cosmic version of stretching taffy. The Milky Way's gravity exerts a stronger pull on the near side of the dwarf galaxy than on its far side, creating a tidal force that overcomes the dwarf's own gravity. This stretches the galaxy, pulling stars away from its main body and scattering them into long, thin streams that trace its orbital path. In most cases, this process is thought to be a complete dissolution. The galaxy is shredded, its stars assimilated into the halo of the larger galaxy, and its identity is utterly erased. But Bootes III tells a different, far more unsettling story. Despite its stars being scattered across an enormous volume of space, they continue to move as a coherent group. Their motions are synchronized, indicating they are still bound together by a powerful, unseen force. The visible galaxy has been annihilated, but something invisible remains firmly in control. This is where the true terror of Bootes III lies. The mathematics of its stellar motions reveal that this scattered stream of stars is still embedded within the original, immense dark matter halo of the progenitor dwarf galaxy. The incredible revelation is that while the Milky Way's tides were powerful enough to tear apart the visible stars, they were utterly incapable of disrupting the dark matter halo itself. This invisible structure has persisted, holding onto its scattered stellar children with an unbreakable gravitational grip. It is the ghost of a galaxy, a dark matter skeleton that continues to orbit the Milky Way long after its body of stars has been dismembered. This forces a profound and alarming revision of our understanding of galactic evolution. We used to think of galaxy mergers as a process where both the stars and the dark matter of a smaller galaxy were eventually blended into the larger one. Bootes III suggests this is only half true. The stars are indeed stripped and assimilated, but the dark matter halo can remain intact, a coherent but invisible structure orbiting within the larger halo of the Milky Way. This means our galaxy's halo is not a smooth, homogeneous cloud of dark matter. Instead, it must be filled with the phantom remnants of countless cannibalized dwarf galaxies, a swarm of dark matter subhalos that are completely invisible to us but whose combined gravitational influence is immense. These ghost halos could be subtly perturbing the orbits of stars within the Milky Way, influencing the shape and evolution of our galaxy in ways we are only beginning to model. Bootes III is a chilling message from the grave, proving that in the cosmos, even death is not an end. The dark matter structures we build can outlive the galaxies they spawned, creating a hidden archaeology of destruction that shapes the universe from the shadows. Deep within the local cosmos, in the constellation named for a mythical king, lies another ghost that defies the brutal physics of our universe. This is Cepheus I, an ultra-diffuse galaxy that presents a survival story so improbable it borders on the miraculous. To our instruments, it appears as little more than a faint, wispy cloud of stars, a structure so ethereal and delicate that it seems it should have been erased from existence eons ago. In the violent, crowded environment of the cosmos, where galaxies constantly jostle and collide, such a faint, low-density object has no right to still be here. Its very existence is a paradox, a cosmic whisper that has somehow endured the shouting of gravitational forces that should have torn it apart. The mystery of Cepheus I's survival centers on a fundamental question of cosmic durability. Imagine a delicate cobweb stretched across a busy hallway. It would be swept away in an instant. In a similar way, the tenuous stellar population of an ultra-diffuse galaxy like Cepheus I should be incredibly vulnerable to any external gravitational disturbance. The tidal forces from nearby galaxies or even the general pull of the galaxy cluster it resides in should have long ago ripped this faint structure to shreds, scattering its stars into the void. The fact that it remains intact, its stars still loosely bound together in a coherent shape, points to only one possible explanation. An unseen, massive anchor is holding it fast against the storm. That anchor, of course, is a massive, dense halo of dark matter. The mathematics are inescapable. For Cepheus I to have withstood the relentless gravitational tides of the cosmos for billions of years, it must be embedded within a dark matter halo with a gravitational grip far exceeding the pull of its visible stars. This dark matter acts as a protective shield, a deep gravitational well that binds the entire structure together with an invisible force, making it far more resilient than its faint appearance would ever suggest. The galaxy we see is merely the tip of a vast, unseen iceberg, its stability entirely dependent on the immense mass of dark matter lurking beneath the surface. This revelation is what generates a deep sense of concern among cosmologists. Cepheus I is not a rare outlier, it is a stark data point in a growing catalogue of ultra-diffuse galaxies that all tell the same story. Their continued existence forces us to accept that the stability of cosmic structures is not dictated by the stars we see, but by the dark matter we cannot. This has terrifying implications for our models of the universe. It suggests that the cosmos is permeated by an invisible scaffolding of immense mass, a hidden architecture that provides the stability for the faintest and most fragile-looking objects. If our understanding of gravity and galactic survival were correct based on visible matter alone, galaxies like Cepheus I should not exist. Their persistence is a powerful testament to the overwhelming dominance of dark matter, proving that what we see is not just a minor component of the universe, but a fleeting decoration on a reality built and shaped by the profound and unseen darkness. But the darkness we've encountered so far may only be a prelude to a far more unsettling reality, a reality embodied by a faint satellite of our nearest galactic neighbor. Drifting through the void in the constellation of Andromeda lies a dwarf spheroidal galaxy known as Andromeda XVII, an object whose very properties seem to push the limits of what we thought was physically possible. On the surface, it appears as nothing more than a faint, diffuse smattering of ancient stars, a ghostly and unremarkable fragment in the vast entourage of the great Andromeda spiral. Yet, when astronomers turned their most powerful instruments toward this seemingly insignificant speck, they uncovered a truth so extreme it forces a complete re-evaluation of the cosmic balance of power. The key to unlocking its secret lay in measuring the motions of its stars. The velocities observed were not just high, they were absolutely frenetic, indicating a gravitational field of immense and concentrated strength. When the calculations were complete, the resulting mass-to-light ratio was not merely high, it was staggering, one of the most extreme values ever recorded. The numbers tell a story that is difficult to comprehend. For every single photon of light emitted by its visible stars, Andromeda XVII possesses hundreds of times more mass in its invisible form. This galaxy is not just dominated by dark matter, it is utterly overwhelmed by it, with luminous matter constituting less than a fraction of a percent of its total substance. It is a place where the visible universe is reduced to a mere impurity, a few scattered grains of sand in a desert of darkness. The profound fear that Andromeda XVII instills in the scientific community is not about its individual strangeness, but about what it implies for the cosmos at large. This object is not a bizarre outlier. It is a terrifying data point that suggests our most extreme models of the universe might still be underestimating the true dominance of dark matter. Our standard cosmological model, known as lambda cold dark matter, already posits a universe that is 27% dark matter and only 5% ordinary matter. But the existence of galaxies like Andromeda 17, with ratios so skewed they defy easy simulation, hints that the true proportion of dark matter could be even higher, its influence even more absolute. It suggests that the ordinary matter we are made of, the stuff of stars, planets, and life itself, might be an even rarer and more insignificant component of the cosmic recipe than we ever dared imagine. This galaxy acts as a cold, hard warning that our place in the universe is not just precarious, but perhaps statistically negligible, a faint flicker in an overwhelming ocean of invisible mass whose true nature and ultimate purpose remain a complete and utter mystery. While the ghostly presence of Andromeda 17 shows us a universe utterly dominated by dark matter, our next discovery reveals just how easily these cosmic phantoms can slip through our nets, hiding in plain sight with a subtlety that is deeply unnerving. This is Hydra II, an ultra-faint dwarf galaxy orbiting our own Milky Way, and its story is one of a near miss that sends a genuine chill down the spine of any astronomer. Imagine an object of significant size and mass, located a mere 130,000 light-years from Earth, a stone's throw in galactic terms, and yet it remained completely unknown to us until 2015. Despite all our powerful sky surveys and meticulous digital scans of the heavens, this galaxy was almost overlooked, its faint signal nearly dismissed as background noise or a statistical fluke in the data. It was only through the painstaking work of astronomers analyzing data from the Dark Energy Survey that this celestial phantom was finally pulled from the shadows, a testament to how desperately close we are to missing entire chapters of the cosmic story. The reason for its near invisibility is its incredible faintness. Hydra II is not just dim, it is one of the lowest surface brightness objects ever discovered. It contains only a few thousand ancient stars flung across a relatively large volume of space. To our most powerful telescopes, it doesn't appear as a cohesive shape or a glowing cloud. Instead, it is detected as a subtle, almost imperceptible statistical overdensity, a region of the sky where the number of pinpoint stars is ever so slightly higher than the random distribution of the surrounding stellar background. Finding it was less like spotting a ship on the horizon and more like identifying a single specific grain of sand on a vast beach by meticulously counting them all. This is not a discovery made by looking at a beautiful picture. It is a discovery made by advanced mathematics and computing power, a ghost revealed by numbers alone. Yet, as with all these dark galaxies, its faint light tells a lie about its true nature. Measurements of the motions of its stars reveal they are moving at velocities that demand a powerful gravitational source. The resulting mass-to-light ratio is once again shockingly high, confirming that Hydra II is another fortress of dark matter, a massive halo of invisible matter that makes up over 99% of its substance, with the visible stars acting as mere accidental occupants. But the truly terrifying part of Hydra II's story is not what it is, but where it is and how it was found. Its proximity to Earth and its near miss in detection act as a dire warning for the entire field of astronomy. If a galaxy of this size with this much mass can hide so effectively just outside our galactic doorstep, how many thousands more are currently eluding our most advanced searches? We have to confront the horrifying possibility that for every faint galaxy like Hydra II we manage to catch, there could be a dozen others that we have already scanned right over and dismissed as nothing. Our current map of the local universe, with its 60 or so satellite galaxies around the Milky Way, is likely a pathetic fraction of the true population. The cosmos could be absolutely teeming with these dark dwarfs, a hidden swarm of massive objects that form the true backbone of galactic halos, their combined gravitational influence silently steering the evolution of galaxies like our own. Hydra II is the tangible proof that we are still effectively blind to the majority of the universe's structure, and that the most common building blocks of the cosmos are not the brilliant spirals we admire, but these invisible, ghostly giants lurking everywhere in the darkness. Pushing further into the faintest frontiers of our galactic neighborhood, we encounter another satellite that defies expectation and amplifies the growing anxiety over our understanding of cosmic structure. Drifting through the constellation of the Fishes is Pisces II, an ultra-faint dwarf galaxy that epitomizes the phrase "still waters run deep." To our most sensitive telescopes, it appears as little more than a handful of ancient stars scattered across the void, a collection so sparse and dim it was only confirmed in 2010 after painstaking analysis of data from the Sloan Digital Sky Survey. Its luminous profile suggests a cosmic afterthought, a failed and fading fragment of the early universe. But as with so many of these dark galaxies, its visible form is a grand deception, masking a hidden reality of immense and troubling gravitational power. Measurements of the velocities of its stars reveal a frantic pace of motion, a chaos of movement that can only be contained by a source of gravity far exceeding the collective pull of every single visible star within it. The calculations point to a mass-to-light ratio that is, once again, staggeringly high. Pisces II, for all its apparent insignificance, is anchored by a surprisingly massive and dense halo of dark matter. This is where the simple observation turns into a profound cosmological crisis. According to our most sophisticated computer simulations of the universe, based on the prevailing cold dark matter model, dark matter should behave in a specific way. It should clump together hierarchically, forming large halos that then attract gas to form galaxies. Crucially, these models also predict that there is a lower limit to this clustering, a scaling relationship between the mass of a dark matter halo and the number of stars it can form. A small, faint galaxy like Pisces II should, by these rules, be hosted by a small, low-mass dark matter halo. Pisces II looks our simulations directly in the eye and declares them insufficient. Its existence presents a direct and frightening contradiction. Here is an object with a tiny stellar population, which should indicate a low-mass dark matter foundation, but instead it is sitting atop a massive, dense concentration of invisible matter. This creates intense anxiety among astrophysicists because it suggests that dark matter might not cluster on the smallest scales in the neat, predictable way we have built our entire understanding of the cosmos upon. The terrifying possibility is that our simulations are not just slightly off. They might be fundamentally flawed in their treatment of dark matter's basic properties at these tiny scales. This opens the door to a host of disturbing alternatives. Perhaps dark matter is not completely cold and collisionless as we have long assumed. Maybe it possesses some small level of interaction, a faint ability to collide with itself or feel other forces, which would prevent it from clumping as efficiently in the smallest halos, altering the predicted relationship between mass and luminosity. Or, even more radically, it could hint that our understanding of gravity itself needs revision on these smallest galactic scales, a possibility that leads us toward theories like modified Newtonian dynamics or MUND, though these two struggle to explain all the observations. Pisces II, therefore, is not just another dark galaxy. It is a critical data point in a growing rebellion against our standard model. It is a faint smudge of light that casts a very long, very dark shadow over cosmology, forcing a humbling admission that the most common substance in the universe continues to behave in ways that defy our best attempts to pin it down. Nestled within the vast stellar stream of the Milky Way's halo, Segue II presents a paradox so extreme it pushes the very definition of a galaxy to its breaking point. Discovered in 2009, this object is not just faint. It is one of the least luminous galaxies ever identified, a collection of stars so sparse and ancient it barely registers as a coherent structure against the backdrop of space. To our most powerful instruments, it appears as little more than a faint smudge, a ghostly remnant containing only a few hundred stars. If you were to stand within it, the nearest stellar neighbor would be light years away, and the sky would be an almost unbroken sheet of blackness. By all appearances, it seems to be a failed cluster, a scattered group of stars on the verge of dissolving into the void. But the motion of those stars tells a completely different and far more unsettling story. They are not drifting apart, they are moving at velocities that indicate a powerful, unseen force is holding them together. The gravitational pull required to keep this faint wisp of light from flying apart is immense, and it far exceeds the combined mass of every single visible star within it. The math leads to one inescapable and disturbing conclusion. Segue II is utterly dominated by dark matter, with a mass-to-light ratio that is among the highest ever measured. This tiny, pathetic collection of stars is in fact the visible tip of a massive, dense, and entirely invisible iceberg of dark matter. This revelation transforms Segue II from a cosmic curiosity into an object of profound terror for astronomers. Its existence raises the frightening possibility that what we are looking at is not a true galaxy at all, but something far more ominous, a fossil. It could be the visible remnant of a much larger dwarf galaxy that was almost completely torn apart by the tidal forces of the Milky Way, its stars stripped away over billions of years to leave behind only its dense, dark matter core and the few stars that were trapped in its deepest gravitational well. This scenario suggests a hidden history of violence and destruction happening right in our galactic backyard, a process of cosmic cannibalism that leaves behind these dark, ghostly cores as the only evidence. Even more chilling is the alternative interpretation that Segue II was never a bright galaxy to begin with. Perhaps it represents an entire class of cosmic object that our models never predicted, a pure dark matter halo that, for reasons we don't understand, managed to capture only a tiny handful of stars during its formation. This idea is truly paradigm-shifting. It suggests the universe could be filled with a vast population of these failed galaxies, structures that possess massive dark matter halos but which, for some reason, never ignited the process of star formation. They would be completely dark, utterly invisible to our telescopes, detectable only by the faintest gravitational tugs they exert on the light of distant quasars or the motion of other visible stars. This is the ultimate fear that Segue II instills. It acts as a single, tangible data point hinting at a hidden multitude. If such a faint object with its significant dark matter content was so difficult to find orbiting our own galaxy, how many more of these failed, starless dark matter halos are drifting through the Milky Way's halo, completely undetectable by any means we currently possess? Our understanding of the universe is built upon what we can see, but Segue II is a stark warning that the cosmos might be primarily built from structures we cannot see, a hidden architecture of failure and darkness that forms the true, silent foundation of reality. And now we turn our attention to a cosmic object whose very existence feels like a direct message from the darkness, a place where the evidence for the invisible becomes terrifyingly tangible. Drifting through the constellation of Berenices Hair is the Coma Berenices Dwarf galaxy, a satellite of the Milky Way that serves as one of the most compelling and unsettling pieces of evidence for dark matter ever discovered. At first glance, it fits the now familiar pattern, an ultra-faint dwarf, a sparse collection of ancient stars so dim it was only pinpointed in 2006. But when astronomers trained their spectrographs on this faint smudge to measure the motion of its stellar inhabitants, they witnessed something that should be impossible within the known laws of physics. The stars within the Coma Berenices Dwarf are not moving with the slow, sedate pace one would expect from such a faint and tiny collection. Instead, they are hurtling through space at astonishing, frenzied velocities. If gravity were solely the product of the visible mass, the combined pull of all those stars, this entire structure would have flown apart eons ago, its stellar members scattered into the void like dust in a hurricane. The fact that it remains intact, its stars bound together in a coherent group, means only one thing: an immense, invisible force is holding it all together. The gravitational anchor required to contain that stellar frenzy is colossal, and it points to a reality where dark matter doesn't just exist, it reigns with absolute, overwhelming dominance. The calculated mass-to-light ratio for this galaxy is staggering, confirming that well over 99.9% of its substance is the invisible grip of dark matter. This is where the discovery moves from compelling evidence into the realm of genuine terror for physicists. The Coma Berenices Dwarf is not an anomaly, it is a stark, in-your-face confirmation of the dark matter paradigm. It provides arguably the cleanest and most direct observational proof that our universe is filled with matter we cannot see. Yet, this very success is also the source of profound anxiety. While the galaxy proves dark matter's existence beyond a reasonable doubt, it simultaneously highlights how utterly little we understand about its fundamental nature. We can measure its gravitational effect with precision, we can map its distribution, we can use it to build models of the cosmos, but we still have no idea what it actually is. We are like ancient astronomers who could perfectly predict the motions of the planets using complex models of celestial spheres, all while being completely ignorant of the force of gravity that truly governed their path. We are describing the effect with growing accuracy while remaining completely blind to the cause. The Coma Berenices Dwarf, in its silent, dark majesty, embodies this terrifying gap in our knowledge. It is a constant reminder that we have built the entire edifice of modern cosmology upon a substance whose identity remains a total mystery. This invisible scaffold dictates the fate of galaxies, holds the keys to the universe's expansion, and constitutes the vast majority of all matter, and yet it eludes every attempt at direct detection. The galaxy's frantic stars are a signal we can read clearly, a message that screams of dark matter's power, but the language of the message itself, the true text of the universe's hidden majority, remains a cipher we have not yet begun to crack. While Coma Berenices presents a clean, stark example of dark matter's gravitational grip, our next destination reveals how this unseen substance might weave structures of a scale and complexity that dwarf even the galaxies they host. In the constellation Leo, we find Leo IV, an ultra-faint dwarf galaxy that on the surface seems to follow the now familiar pattern: a sparse collection of ancient stars, a high mass-to-light ratio, and a dominant dark matter halo. But Leo IV holds a secret far more unsettling than simply being massive for its size. It appears to be not just a galaxy, but the luminous heart of something infinitely larger and almost entirely invisible. The initial intrigue around Leo IV came from the motions of its stars, which confirmed the presence of a significant dark matter anchor. However, the true revelation emerged when astronomers began mapping the positions and velocities of stars in the vast region of space surrounding this faint galaxy. They discovered something extraordinary: a faint, elongated stream of stars, a cosmic trail that seemed to extend far beyond the galaxy's main body. This stream is not a random scattering, it is a coherent structure, a ribbon of stars all moving in concert, tracing a path through the void. Such stellar streams are the telltale signatures of tidal disruption, often created when a small galaxy is pulled apart by the gravity of a larger one. But Leo IV is largely intact. The stream isn't coming from it, it seems to be enveloping it, suggesting the galaxy is merely the brightest knot in a much larger, darker filament. This is where the story shifts from intriguing to genuinely concerning. The sheer scale and coherence of this stellar stream demand a gravitational explanation far beyond what the visible matter in Leo IV could provide. The only force powerful enough to sculpt and hold such an immense structure together is the gravity of an enormous, extended dark matter halo, one that stretches far beyond the few visible stars we associate with the galaxy itself. Leo IV, in this view, is not the entire structure. It is simply the one place where this vast, invisible dark matter filament was dense enough to capture a handful of gas and form a few stars. The true, underlying dark matter structure is likely orders of magnitude larger than the galaxy we have named and catalogued. This discovery forces a terrifying revision of our mental map of the cosmos. We are used to thinking of galaxies as discrete islands in the void, each with its own dark matter halo. Leo IV suggests this is a profound oversimplification. It implies that dark matter forms a cosmic web of filaments and tendrils on a scale we can barely comprehend, and that the galaxies we see are merely where that web is densest, like dewdrops clinging to a vast, invisible spiderweb stretched across the universe. The luminous galaxy is just a tracer, a tiny marker for a hidden leviathan of dark matter that extends into the intergalactic darkness. The fear this generates is not about the existence of the dark matter web cosmologists have predicted its existence for decades, but about its sheer dominance and our inability to perceive its true form. Leo IV acts as a chilling warning that the dark matter halos we think we are measuring for these faint galaxies might only be their cores. Their true extent, their tendrils and connections to the larger cosmic web, could be vastly greater than our models allow. This means the total mass of dark matter in the universe and its gravitational influence on the expansion and ultimate fate of everything could be even more overwhelming than our most extreme estimates. We are not just missing the matter, we might be missing the true gargantuan architecture of the matter, an invisible framework of such complexity and scale that the brilliant galaxies we admire are nothing more than fleeting, incidental ornaments. And now we venture into the constellation of the hunting dogs, where a small, faint satellite of the Milky Way presents a puzzle that strikes at the very heart of the relationship between the visible and invisible cosmos. This is Cain's Venatici II, a dwarf spheroidal galaxy whose story is not written in the frantic motion of its stars or its overwhelming mass, but in the silent, enigmatic history of its star formation. Unlike the sterile darkness of Segue I or the protective cradle of Leo T, Cain's Venatici II holds a record of creation that is both incomplete and deeply confusing, a chronicle that suggests the hand of dark matter is far more active and intrusive than we ever imagined. When astronomers study a galaxy, one of the key clues to its history is its color magnitude diagram, a kind of cosmic family tree that reveals the ages and types of its stars. For most ultra-faint dwarfs, this diagram tells a simple, bleak story, a single, ancient burst of star formation over 12 billion years ago, followed by an eternal silence. Their populations are uniformly old, red, and metal-poor. Cain's Venatici II shatters this expectation. Its stellar population is not uniform. While it does possess that ancient foundation, it also shows evidence of a much more complex and extended history. There are signs of intermediate age stars, suggesting that star formation did not simply shut off after the initial burst, but sputtered on intermittently for billions of years, like a fire that refuses to be fully extinguished. This is profoundly unusual for a galaxy of its size and environment. The relentless tidal forces of the Milky Way and the evaporative effect of ultraviolet radiation from intergalactic space should have stripped away its gas reservoir almost immediately, shutting down any chance of continued star formation. The fact that it didn't hints at a powerful protective force. That force, of course, is its dark matter halo, whose deep gravitational well likely provided a shelter, allowing Cain's Venatici II to cling to its gas far longer than should have been possible. But this is where the story turns from unusual to truly frightening. The star formation history isn't just extended, it is also strangely synchronized and punctuated. It didn't proceed at a steady, slow trickle. Instead, it seems to have occurred in distinct, isolated episodes, as if a switch was being flicked on and off by an unseen hand. This bizarre pattern is what generates a deep and unsettling fear among astrophysicists. The prevailing theory has always been that dark matter's influence is purely gravitational. It creates the potential well, and then ordinary physics, the cooling of gas, the triggering of supernova, the shockwaves from stellar winds, takes over to govern the rhythm of star birth. Kane's Venatici II challenges this passive view. Its erratic but coordinated star formation pulses suggest that dark matter itself might be directly influencing the baryonic matter within it through mechanisms that go far beyond gravity. What if dark matter isn't just a scaffold, but an active participant in the physics of galaxy formation? The terrifying possibility is that dark matter could possess its own complex physics, with interactions that generate heat, produce radiation, or even create pressure waves that periodically compress gas clouds and trigger starbursts from within the shadows. This idea moves us from the comfortable realm of known physics into a frontier of pure speculation and profound mystery. It forces us to consider that the 85% of the universe's matter we cannot see might not be inert. It could be dynamic, churning, and capable of influencing the 5% we are made of in ways we have no instruments to directly measure and no theories to fully explain. Kane's Venatici II, with its cryptic stellar genealogy, acts as a single, faint data point suggesting that the divide between the dark and light sectors of the universe might not be as clean as we thought. The fear is that we are not just mapping an invisible structure, but attempting to decipher the actions of an invisible actor, one whose rules we have not yet learned and whose influence on the story of creation might be far more direct and mysterious than gravity alone. Nestled within the expanse of the Great Bear constellation, Ursa Major I exists at the very edge of perception, a ghost so faint it pushes our most advanced telescopes to their absolute limit. This dwarf spheroidal galaxy is not merely dim, it is one of the least luminous objects ever granted the title of galaxy, a collection of stars so sparse and ancient that it barely registers against the profound blackness of the intergalactic void. To our instruments, it appears as little more than a statistical anomaly, a region of the sky where the density of pinpoint stars is ever so slightly higher than the random background, a whisper so quiet it was almost lost in the cosmic static. Its discovery was an act of astronomical patience, a testament to our growing ability to find the nearly invisible. Yet, this extreme faintness is but a mask for a hidden reality of immense and terrifying gravitational power. When astronomers measured the velocities of the few stars within this tenuous structure, they encountered a paradox that defies logic based on the visible universe alone. These ancient suns are moving at frenetic, chaotic speeds, hurtling through their orbits with an energy that the combined gravity of every single visible star could never hope to contain. The mathematics of their motion paints an inescapable and startling picture. To prevent this entire wisp of a galaxy from instantly flying apart requires a gravitational anchor of immense and concentrated strength. The resulting mass-to-light ratio is not just high, it is one of the most extreme values ever recorded, a number so staggering it leads to a single, shocking conclusion. Ursa Major I is composed of over 99.9% dark matter by mass. It is not a galaxy of stars with some dark matter. It is a colossal fortress of pure, invisible mass that has, almost as a forgotten afterthought, managed to ensnare a handful of stellar stragglers. This revelation is what propels Ursa Major I from a curious oddity into a realm of profound and genuine terror for cosmologists. It presents the most terrifying possibility yet, that dark matter does not require visible matter to form a massive structure at all. This galaxy suggests that the invisible scaffolding of the cosmos can coalesce into immense halos entirely on its own, creating gravitational islands in the void that are completely self-sufficient. The few stars we see might not be native to this structure. They could be interlopers, ancient stars that wandered too close to this dark matter well billions of years ago and became permanently trapped in its irresistible grip like flies caught in an invisible web. This transforms our understanding of galaxy formation from a collaborative process between dark and light matter into something far more sinister and independent. The existential fear this galaxy instills is not about its individual properties, but about the overwhelming statistical implication it carries. If dark matter can form such massive, coherent structures without needing to ignite a single star, then the universe could be teeming with a hidden population of completely black galaxies. These would be structures of pure dark matter, utterly invisible to every telescope ever built, detectable only by the subtlest gravitational lensing effects on the light of objects far behind them. Ursa Major I, as one of the faintest objects we can see, might merely be the tip of the iceberg, the one structure where we got lucky and found a few tracer stars to betray the presence of the true, unseen behemoth lurking beneath. This forces a chilling admission: our entire census of the cosmos, built upon the foundation of what emits light, could be missing the majority of its actual architecture. The brilliant tapestry of galaxies we map and admire may be nothing more than rare ornaments on a universe built overwhelmingly from dark, silent, and terrifyingly alien structures that obey a physics we are only beginning to guess at. And so we arrive at our final destination, a place that may represent the ultimate fate of all galaxies, a cosmic ghost story that speaks of endings rather than beginnings. In the constellation of the Herdsman, there drifts an object known as Bootes II, an ultra-faint dwarf galaxy that feels less like a living structure and more like a tombstone. To our most powerful instruments, it appears as little more than a faint smattering of ancient stars, a handful of dying embers scattered across an unimaginable volume of space. Its light is so feeble, its form so tenuous, that it barely qualifies as a coherent object at all. But this apparent insignificance is the most terrifying deception of all, for Bootes II is not a newborn galaxy. It is a corpse, and it offers us a chilling premonition of the universe's final state. The story of Bootes II is written in the motions of its few remaining stars. They move with a frantic, chaotic energy, velocities so high that the gravitational force required to hold them together is immense. When astronomers did the math, they arrived at a shocking conclusion. The visible stars account for less than 1% of the mass creating that gravity. The overwhelming majority, the 99.9%, is the silent, unseen grip of dark matter. This galaxy is not merely dominated by dark matter, it has been consumed by it. The luminous matter has been almost entirely erased, leaving behind only the dark matter skeleton of what was once a much larger, vibrant galaxy. This is where the true horror of Bootes II comes into focus. Astronomers now believe this faint wisp is not a primordial object but a ghost, the final remnant of a dwarf galaxy that was once far more substantial. Billions of years ago, it likely ventured too close to the immense gravitational field of our Milky Way. Over eons, the tidal forces of our galaxy acted like a cosmic cheese grater, relentlessly pulling and stretching the smaller galaxy. The stars and gas, the visible components, were the first to go, stripped away by the tidal pull and scattered into the Milky Way's halo to form faint stellar streams. But the dark matter halo, bound by gravity alone and immune to tidal friction, remained largely intact. What we see today as Bootes II is likely just the dense, dark matter-rich core of that original galaxy, a fossilized heart that has outlived its own body. This transformation represents a frightening and inevitable stage of galactic evolution, a process that is happening all across the universe in galaxy clusters and groups. It forces us to confront a future where dark matter is not just the hidden foundation of the cosmos, but its only lasting component, The brilliant ballet of stars, the glowing nebulae, the potential for planets and life, all of it is temporary, a fleeting spark in the cosmic darkness. The galaxies we see today, with their majestic spirals and brilliant clusters, will eventually share the fate of Bootes II. They will be cannibalized, stripped, and merged until all that remains are their indestructible dark matter halos, silently orbiting each other in a black and empty void. Bootes II is a message from the future, a preview of a time tens of billions of years from now when the universe will be a much darker, quieter, and lonelier place. Its history written not in starlight, but in the immutable, invisible geometry of dark matter. As we conclude this journey through the haunting realm of these 25 dark galaxies, a profound and unsettling truth begins to crystallize. These are not merely cosmic oddities or distant curiosities. They are fundamental challenges to our very understanding of reality. Each one, from the ghostly giant crater 2 to the violently annihilating core of Triangulum II, acts as a stark counterargument to the clean, predictable universe we thought we inhabited. They force us to confront a cosmos where the rules are not just unknown, but perhaps wildly different from anything we have ever imagined. The sheer prevalence of these objects suggests that what we see with our telescopes, the glittering tapestry of stars and spirals, is nothing more than a decorative veneer, a luminous froth on the surface of a deep, dark, and overwhelming ocean of invisible matter. These dark galaxies represent the precise frontier where our current models of physics and cosmology break down. They are the anomalies that keep scientists awake at night, the data points that refuse to fit neatly into our equations. The existence of a galaxy like Dragonfly 44, with the weight of a freight train but the appearance of a feather, shouldn't be possible under our standard theories. The missing dark matter in NGC 1052 DF2 and DF4 shouldn't be possible. The ancient dark matter-dominated fossil that is Tucana II shouldn't have been able to form so quickly. Yet they all exist, screaming their contradictions into the void and demanding a revolution in our thinking. They hint that dark matter is not a single, simple substance but something far more complex, capable of clustering, interacting, and influencing the visible universe in ways that defy our current grasp of particle physics. This forces a humbling admission. We have been mapping the universe with a severe bias, cataloging only what shines and largely ignoring the invisible architecture that truly holds everything together. The fear is not just that we don't know what dark matter is, but that our entire census of the cosmos is catastrophically incomplete. For every brilliant galaxy we have charted, there could be a dozen or even 100 dark counterparts drifting unseen through the void. Their combined gravitational influence is likely steering the evolution of the galaxies we can see, warping the cosmos on a grand scale from behind a veil of perfect blackness. We are like sailors on an ocean who have only just realized that the visible waves are dwarfed by immense, unseen currents surging deep below, currents that control our ultimate destination. So what other dark secrets is the universe hiding in plain sight? The discovery of these 25 galaxies is not an end point but a beginning. It is a powerful reminder that the greatest mysteries are not always found in the most distant reaches of space, but sometimes in the faint, overlooked whispers closer to home. They encourage us to keep looking, to develop new ways of seeing, and to remain open to the possibility that the true nature of reality is far stranger, more complex, and more terrifyingly beautiful than we have ever dared to dream. The darkness is not empty, it is full of answers waiting for the right question.